Hey everyone, are you ready to explore the fascinating world of engineering? Let's dive in. Oscillators are essential electronic circuits that generate repetitive signals, playing a crucial role in modern technology. They power digital clocks, enable communication systems, and serve as the backbone of countless electronic devices. In this video, we'll break down how oscillators work, explore different types like sine wave and square wave generators, and see how they're used in everyday technology. By the end, you'll have a solid understanding of these incredible circuits and their impact on modern electronics. Let's get started. What is an oscillator? An oscillator is an electronic circuit designed to generate periodic signals in the form of waveforms. These signals can take different shapes, such as sine waves, square waves, or other patterns, each suited for specific applications. 1. Sine wave oscillators produce smooth, continuous signals, making them ideal for audio and radio frequency applications. 2. Square wave oscillators generate sharp, distinct pulses, commonly used in digital circuits. Oscillators are fundamental to communication systems, enabling data transmission across distances. They also play a crucial role in signal processing, ensuring precise timing and synchronization in electronic devices. Understanding oscillators is key to grasping how modern electronics function. Components of an oscillator. Oscillators rely on several key components to generate periodic signals. These include 1. Resistors, control the flow of current. 2. Capacitors, store and release electrical energy, creating the necessary time delay for oscillation. 3. Inductors, store energy in a magnetic field, contributing to the oscillation process. Together, these components form feedback loops that sustain continuous oscillation. Common types of oscillator circuits include 1. RC, Resistor-Capacitor oscillators, which use the charging and discharging of capacitors to generate waveforms. 2. LC, Inductor-Capacitor oscillators, which rely on resonance between inductors and capacitors. Understanding these components is essential for learning how oscillators function in different applications. Principles of oscillation. Oscillators operate based on a feedback mechanism that continuously reinforces the signal. A portion of the output is fed back into the input, creating a loop that sustains oscillation. To maintain stability, this feedback must be carefully controlled. 2 key concepts in oscillation are 1. Resonance. When a circuit's natural frequency matches the input signal's frequency, amplifying oscillation. 2. Energy transfer. As energy moves between capacitors and inductors, it generates the desired waveform. These principles explain how oscillators consistently produce signals, making them vital for various electronic applications. Types of oscillators. There are different types of oscillators, each with unique characteristics. 1. Crystal oscillators, highly precise and stable, using quartz crystals to maintain a fixed frequency. 1. Found in clocks, watches, and communication devices. 2. Relaxation oscillators generate non-sinusoidal waveforms like sawtooth or square waves. 2. Used in timers and audio applications. 3. Ring oscillators consist of inverters connected in a loop, producing a square wave output. 3. Commonly used in integrated circuits for clock generation. Each type serves a specific function in electronics, showcasing the versatility of oscillators in modern technology. Building a simple oscillator circuit. Building a basic oscillator circuit is a great way to understand its working principles. Here's what you'll need. 1. 1K resistor. 2. 10 UF capacitor. 3. 505 timer EC. 4. Breadboard. 5. Jumper wires. 6. 9V battery power supply. Step-by-step instructions. 1. Place the 555 timer IC on the breadboard. 2. Connect the resistor between pins 7 and 8. 3. Attach the capacitor between pin 6 and ground. 4. Link pin 6 to pin 2 to create feedback. 5. Connect pin 3 to an output device, such as an LED. 6. Power the circuit by connecting pin 8 to the positive terminal and pin 1 to ground. Try experimenting with different resistor and capacitor values to see how they affect the output frequency. Applications of oscillators. Oscillators are used in a wide range of electronic systems. 1. Radios generate carrier waves for transmitting and receiving signals. 2. Clocks maintain precise timekeeping by producing stable frequency signals. 3. Signal modulation encode and decode data for communication and information transmission. 4. Computers, smartphones, and televisions synchronize processes and ensure stable performance. Their ability to generate consistent frequencies makes oscillators an essential component in both consumer and industrial electronics. To summarize: 1. Oscillators are fundamental electronic circuits that generate periodic signals. 2. We explored various types, including crystal, relaxation, and ring oscillators. 3. Understanding their components and principles helps us appreciate their role in modern electronics. Thanks for watching, and stay tuned to TechBlueprint for more exciting and practical engineering content.